Good morning, students. In the previous class, we see how to find the given system of equations by a rank method. Now we continue the problems. We see the second one, the same exercise. Determine the values of a lambda. To find the value of this lambda, which are the following system of equations. There will be three equations, 1, 2, and 3. You see all the equations oranges are 0. So the name of the equation is called homogeneous. Okay, has a unique solution and a non-trivial solution. We already tell what is meant by trivial and non-trivial. A solution set contains all values of 0 is called trivial. So a solution set contains at least any one non-zero, it is called non-trivial. So in which value of lambda the given system has a unique and the trivial solution. What is the first step? To write the given system of equation in matrix form. It is the first step. The matrix form is to convert the given system of equation in matrix form. Okay, in matrix form, first equation lies in the first row of the matrix. Matrix symbol. First one is the values of coefficient of x, y, z, and the second matrix is the values of x, y, z, and RHS is the constants. Now we enter the values. The first one is the coefficient of x, y, z in the first equation. Okay, you see it is the first equation, whose coefficients of x are 1, y is 1, and z is 3. So 1, 1, 3 lies in first row. 1, 1, 3. And now we see the second equation. Coefficient of x is 4, y is 3, and z is lambda. 4, 3, lambda. Third equation. Coefficient of x is 2, y is 1, and z is 2. So 2, 1, 2. 2, 1, 2. Here the variables x, y, z. You see all the RHS are 0, 0, 0, 0. So RHS values are 0. Now it is of the form Ax is equal to 0. We say it is a matrix A. It is a matrix capital X. Or it is a 0 matrix or 0 or O. Ax is equal to 0. After converted in matrix form, the next step is to create an augmented matrix. The augmented matrix is, how to write? A bar 0. 0 or O, because RHS matrix fully contains 0. First we write the matrix A values. The values of A. 1, 1, 3. 4, 3, lambda, 2, 1, 2. It should be extended by the RHS matrix. It contains fully 0. 0, 0, 0. After writing the augmented matrix, the next step is to convert this augmented matrix in echelon form. You see, already the first row, first matrix element is just 1. So no change in the first row. And you see our value is fully involving lambda. But the lambda lies in the middle row, second row. For our easy convenience, first we interchange. This lambda lies in the third row. We write as it is the second row also lambda lies. For our easy convenience, we interchange R2 and R3. So no change in the first row. First of all, I interchange the second row and the third row. So it is not an equal matrix, it is a equivalent matrix. So equivalent symbol. We write first row as it is. The first row 1, 1, 3, 0. 1, 1, 3, 0. And now I interchange the second row and third row. Okay, so we write R2 interchange R3. So the third row becomes the second row, and the second row becomes the third row. Third row 2, 1, 2, 0. 2, 1, 2, 0. Second row become the third row. 4, 3, lambda, 0. 4, 3, lambda, 0. The next step, to convert this element is 0, and the next step to convert that element is also become 0. So no change in the first row. 1, 1, 3, 0. Second row. Our aim is to convert that element become 0. So we consider in which rows? R2 and R1. 2, 1. So just we multiply 2 by R1. 2 minus 2 become 0. Both have the same sign. So how to write R2? We write R2 as, that is second row fully as second row minus 2 times of the first row. So we write R2 as R2 minus 2R1. Second row minus 2 times of the first row. 2 minus 2, 0. All the remaining elements is also important. 1 minus 2 ones are 2. 1 minus 2 is minus 1. The number 2 becomes 2 minus 2 3s are 6. 2 minus 6 is minus 4. 2 minus 6 is minus 4. All the numbers are 0, so we write 0. Because the 0 operation, 0 and anything is always 0. Next is to convert that element 4 is also become 0. So we consider in which rows? It is your choice. We consider either R3, R2 or R3, R1. Now I consider R3 and R1. Our motive is to convert this element become 0. So we write R3 as R3 minus 4 times of R1. So we write R3 as R3 minus 4R1. We write the order fully as a third row minus 4 times of the first row. So 4 minus 4 ones are 4. 4 minus 4 is 0. 3 minus 4 ones are minus 4. 3 minus 4 again minus 1. But this is lambda. Okay, lambda minus 4 times of R1. Minus 4 3s are 12. So how to write? Lambda minus 12 is lambda minus 12. These two values are 0. So you write as it is 0. It is in echelon form? No, it is not in echelon form. We do one more work. What is the work? To convert this element is also become 0. Now you have an idea. We check R3 and R2. Just we separate these rows. We write R3 as R3 minus R2 because both have the same sign. Suppose we separate, this element is also become 0. Then it is in echelon form. Now no change in the first two rows. 1, 1, 3, 0. Second row 0, minus 1, minus 4, 0. Now we write this R3 as R3 minus R2. We already tell after converting these two elements becomes 0, we consider only the R2 and R3. Both they have the same number, same sign. So to separate. So how to write R3? R3 as R3 minus R2. 0 minus 0, 0. Minus 1, minus of minus 1, plus 1. Minus 1 plus 1, 0. Lambda minus 12 becomes how to write R3? R3 minus R2. Lambda minus 12 minus of minus 4. Lambda minus 12 minus of this minus 4. You know this minus to minus is plus. So lambda minus 12 plus 4. Minus 12 plus 4 is a minus 8. Lambda minus 8. I say all values are 0. Because 0 minus 0 is 0. Now you see it is in echelon form. The first row, first element is non-zero. And at least the triangle shape of element become 0. Now using these values of lambda, the given system as unique and non-trivial. So it is in echelon form. So we write it is in echelon form. Our question is not to find the solution. Our question is in which value of lambda the given system has unique and non-trivial. What is the first subdivision? Unique solution. First one. Unique solution. We put in which value of lambda the given system has unique. You know, it is last column full is 0, it is homogeneous. In a homogeneous, when the system has unique, both the rank should be equal and also is equal the number of unknowns. Okay, what is the number of unknown here? 3. Suppose the given system has a unique solution, both the rank of a by 0 and a are exactly is equal to 3. So it is possible only when this one is non-zero. Because one non-zero row, two non-zero row. Suppose lambda minus 8 is not is equal to 0, we have the third non-zero row. So unique solution is possible only when the value of lambda is not is equal to 8. We put except 8, any real number, it is a non-zero row. Suppose we put exactly lambda value is 8, it becomes 8 minus 8 is 0. So the system has a unique solution only when the value of lambda minus 8 it should be not is equal to 0. When lambda minus 8 is not is equal to 0. So what about lambda? So lambda is not is equal to 8. Suppose we put the value of lambda, any value except 8, because lambda is not is equal to 8. Row of a by 0 and row of a, I say both the rank should be is equal to 3. How it is 3? 1 non-zero row, 2 non-zero row. We already tell the value of lambda is not is equal to 8. So it is also a non-zero element. So the third row is also a non-zero row. So row of a by b is 3. And we leave the last column, row of a is also 3. Where 3 is nothing but our given number of unknowns. Therefore, the system has a unique solution for the value of lambda is not is equal to 8. You identify the given system as a unique solution only when the value of lambda is not is equal to 8. What is the second one? A non-trivial solution. The another name of non-trivial is nothing but infinitely many solution. So the solution that contains any one of the element is non-zero is called a non-trivial. How do you identify when the given system has a non-trivial? It is opposite of a unique. Suppose exactly that value is also become 0. Exactly we put the value of lambda is 8. 0. We count the number of non-zero rows, just 2. 1, 2. Third row is vanish. Suppose both the rank is less than the number of unknown, then the system has infinitely many solution, but here given is a non-trivial solution. So when a non-trivial solution is possible, the value of lambda is exactly is equal to 8. So we write when lambda minus 8 is equal to 0, which implies the value of lambda is exactly 8. Okay, lambda value is exactly 8. Then we check row of a by 0 and row of a is exactly is equal to 2. Now you see the last echelon form 1, 2, okay. Now we put lambda value is also 8. 8 minus 8 is 0. So third row fully 0. So number of non-zero rows 1 and 2. So I say both the rank should be is equal to 2, where the number 2 is less than the given number of unknowns. Therefore, the system as a non-trivial solution. Put a heading. The system has a non-trivial solution for the value of lambda is equal to 8. You underline? Non-trivial is possible only when the value of lambda is equal to 8. So our question is, we find the value of a lambda. Suppose the system has a unique and a non-trivial. So the given system has a unique solution only when the value of a lambda is not is equal to 8. And the given system has a non-trivial, or another word is infinitely many solution, is possible only when the value of a lambda is equal to 8. Now you see the third one, using some chemical equation. By using the Gaussian elimination method, you remember Gaussian elimination method is nothing but a rank method. Balance the chemical equation. C2H6 plus O2 gives H2O plus CO2. You know very well how to balance the chemical equation. But now we balance this chemical equation by using the Gaussian elimination method. When we balance the chemical equations, the numbers occur in front of all organs. Suppose 2, 4, 5, 6. Some number is occur. So if we take first of all, let there will be 4 unknown values, x1, x2, x3 and x4 be the positive integer such that. So numbers occur in front of C2, O2, H2 and C. So if we take arrange, the first one is x1, second term is x2, third is x3 and fourth is x4. You know very well all are positive number, so if we take it is a positive integer. So if we take the unknown numbers as x1, x2, x3 and x4 such that the first compound there will be x1 number is there. If we take, so if we take it is x1 C2H6. It will be taken in order. So first one compound outside is x1 C2H6 plus O2. The oxygen. We will be taking the x2 number of oxygen is there. So how to write? Plus x2 O2 gives. We will be taking the first one is x1 is x2 and gives the third one is x3. So we will be take x3 H2O. So next one is x4 x3 over plus x4 times of CO2. Now our motive is to find the values of this x1, x2, x3 and x4. So we use these equations, so I put it is equation 1. Now to find the values of this unknown x1, x2, x3, x4 by using Gaussian elimination method. The next step is equating. Just start we equate the number of carbons, the number of hydrogens and the number of oxygens. Okay, in LHS we take it is LHS and another one is RHS. So numbers are occur here, we don't have the number, so if we take the numbers values as x1, x2, x3, x4. Now we find the values from x1 to x4 by using Gaussian elimination method. So first we form the system of equations. So first we equating the number of carbons, hydrogens and oxygens. Now first of all we take the first letter is C. So how many carbons in first of all C? 2. So there will be 2 carbons. So we write it is 2 times of x1. Okay, 2 times of, we don't have the values of this x1. So 2 times of x1 we equate, so is equal to. So there is no C2 in LHS. Now we move in RHS. The first term there is no carbon term. In second one CO2. So how many carbons? There will be only 1 carbon. This 2 is only for oxygen. O. So only 1 carbon. So 1 times of x4. So how to write? 2 times of x1 we write it is 2x1 is equal to x4. 1 times of x4 is x4. I write this is 2x1 minus x4 is equal to 0. You write 1 by 1 also. For easy convenience, I frame a 3 equations here. So I write step by step. So first of all, I equate the carbons, both LHS and RHS. Next, the neighbor of carbon, the next one is hydrogen. H is there. How many hydrogens is there? H6. So there will be H6. So 6 of X1. So 6 into X1. The next term there is no hydrogen. So is equal to. Now we move in RHS. X3, H2O. How many hydrogens? 2 hydrogens. So we write it is 2 of X3. 2 of X3. We don't have the value of X3, therefore 2 times of X3. Next we check. The hydrogen term is lies in the next term also. You see? There is no H in the last term. 6x1 is equal to 2x3. 6x1 minus 2x3 is equal to 0. 6x1. Suppose the plus term becomes that side, minus 2x3 is equal to 0. You see any number is common here? The number 2 is common. So I divided by 2, it becomes 3x1 minus x3 is equal to 0. We divided by 2. 3x1 minus x3 is equal to 0. Now the third element. Carbon, hydrogen over. The next one is oxygen. In LHS, O2, there will be 2 oxygen of X2. 2 X2 is equal to. Now we move in RHS. You see the first term, how many oxygens? 1 oxygen, just O is there, so only 1. So 1 times of X3. The next term is also contains oxygen. So plus O2. How many oxygens? 2 oxygens. So 2 of X4. So we write it is 2x2. 2x2 is equal to x3 plus 2x4. The simplification is your choice. I will be take that value, it become RHS. So we write it is 0 is equal to, plus term become that side, minus 2x2 plus x3 plus 2x4. How to write? We write it is minus 2x2 plus x3 plus 2x4 is equal to 0. So it is the first step to form some equations according to our chemical equations. What is the first step? We have some numbers occur in front of the elements carbon, hydrogen and oxygens. We don't have the number, we will be taking order x1, x2, x3, x4 is the first step. The next step, we equating the given elements. We equating first of all carbon, hydrogen and oxygen. We equating some elements is occur. For our convenience, we will be taking x1, x2, x3, x4. In example also, we will be taking x1, x2, x3, x4. Suppose that I will be taking x, y, z and some number. Okay, it's your choice. We will be taking. Now I will be taking x1, x2, x3, x4. So when we equating, we form some equations. Now you see how many equations are framed. 1, 2, 3. And how many unknowns are there? How many unknowns? Is the number of unknowns are 4 from x1, x2, x3, x4. So it is a system of equations. The first step to form a system of equations. What is the next step? After we finding the system of equation, the next step to convert the system of equation in matrix form. So the next step to convert it in matrix form. So the matrix form is, the next step is to convert this one in matrix form. The matrix form is, some numbers are missing, it's very important. All the time is not there. After x1 we need x2. You see there is no x2. And also x3 term is not there, but x4 term is there. So we write each and every elements. So how to frame the, you know very well, the first equation lies the first row, second equation lies the second row, and the third equation lies the third row. Now I write in matrix form. Always the first equation lies the first row whose coefficients. First one, x1. What is the coefficient of x1? Is 2. Actually the next term of x1 is x2 is not there. So how to write? It is 0. 0 into x2 is 0. So 0. x3 term is also is not there. So 0. x4 term is there. Minus x4. So how many times? Minus 1. Okay. First equation, first row finished. Next, second equations. You see the second equation, first one, 3x1. So what is the coefficient of x1? Is 3. Next one, coefficient of x2 is not there. So it is 0. And minus x3. So coefficient of x3 is minus 1. And you see x4 term is missing. So 0. Now you see the third one. Minus 2x2. So x1 term is missing here. So 0. And coefficient of x2 is minus 2. Coefficient of x3 is 1. And coefficient of x4 is 2. Now I check 2x1, 0, 0, minus x4. 3, 0, minus 1, 0. 0, minus 2, 1, 2. And here the values are from x1 to x4. So x1, x2, x3, x4. RHS is 0, 0, 0. So the first column is the values of coefficient of x1. Second column is the coefficient of x2. Third column is coefficient of x3. And the fourth column is coefficient of x4. Now we multiply, we get the equations. I check 2 into x1 to x1. 0, 0. Minus 1 into x4 minus x4 is equal to 0. Second equation. 3 into x1, 3x1. 0 into x2, 0. Minus 1 into x3 minus x3. 0 into x4, 0 is equal to 0. Third equation. 0 into x1, 0. Minus 2 into x2 minus 2x2. Plus 1 into x3, x3. Plus 2 into x4, 2x4. So the first step to form a matrix form. After converting the matrix form, what is the next step? Now it is of the form. It is of the form Ax is equal to 0. Ax is equal to 0. After converting in matrix form and also Ax is equal to 0, the next step, the augmented matrix. Okay, this matrix form is extended by the RHS. Here the RHS is also 0. So after converting in matrix, the next step is to form an augmented matrix. The augmented matrix is a matrix A, is extended by the RHS. The RHS also all are 0. After writing the augmented matrix, next to convert the matrix in echelon form. So first we check is a non-zero. Yes, it is non-zero. If any chance to convert it is 1, first we convert it is 1. But it is 2, 3 and 0. Suppose it is divided by 2, some fraction is occur. So in this situation, no change in the first row. We write as it is the first row. So 2, 0, 0, minus 1, 0. I don't change the first row, I write this number 2. The next aim is to convert that element become 0. But 3, 2 is there. The numbers are differ. You know the working rule, if the numbers are differ, then we interchange the numbers. Okay, we interchange the rows. So our aim is to convert the number 3 become 0. So how to write R2? We write the second row fully as 2 times of R2 minus 3 times of R1. So we write R2 as We interchange the number 2 times of R2 minus, what is the reason to put minus? Both are the same sign. Minus 3 times of R1 minus 3 of 1. So 2 3s are 6, minus 3 2s are 6. 6 minus 6 is 0. All the numbers are 0. Both the numbers are 0, so 0. Minus 1. We write R2 as 2 R2. 2 into minus 1. Minus 2 minus 0. So minus 2. 0. 2 into 0. 0. Minus 3 into minus 1. Minus 3 into minus 1. So minus and minus is plus 3. Okay? You don't consider 2 into 0 is 0. Minus 3 of minus 1 is plus 3. Both the numbers are 0. So the process is 0. Already in this sum, that element becomes 0. So we write third row. 0, minus 2, 1, 2, 0. Now you see it is in echelon form. 0. The number is also become 0. But after converting these two elements become 0, we consider only R2 and R3. But you see it is 0. The number is 0. Suppose we do any process, it cannot be changed because this element is also 0. But our motive is to convert this element is also become 0. So what is the way? You don't see the first row. Because when we interchange, the number 2 is occur. You have any idea? Just we interchange these two rows, R2 and R3. The 0 element automatically come here. So the next step, we interchange R2 and R3. So now change the first row. So first row we write as it is 2, 0, 0, minus 1, 0. Now I interchange R2 and R3. Second row become the third row and the third row become the second row. So third row 0, minus 2, 1, 2, 0. 0, minus 2, 1, 2, 0. And the second row become the third row. 0, 0, minus 2, 3, 0. 0, 0, minus 2, 3, 0. Now you see it is in echelon form. So it is in echelon form. Here, row of A by 0 and row of A is equal to row of means the rank. What is the rank of the augmented matrix and the matrix A? Now I say the rank is 3. You see 1 non-zero row, 2 non-zero row and 3 non-zero row. And we leave the last column is also the rank is 3. The number 3 is equal to the number of unknown. Here what are the number of unknowns? From x1 to x4, how many unknowns? 4. x1, x2, x3, x4. So 3 is less than the given number of unknowns. So all the oranges are vanished, 0. So what is the name of the system? Is homogeneous. In a homogeneous, the given number of rank is less than the number of unknown, then what is the possibility of solutions? The possibility of solutions is it has infinitely many solutions. Therefore, the system has infinitely many solutions. Because it's less than number of unknown, then system has infinitely many solutions. But we need only one values of x1, x2, x3, x4. But the system has infinitely many solutions, then we'll be taking only the positive integers. Because it's above the rank is less than the number of unknown, then the system has infinitely many solutions. Next, we find the solution. What is the next step? We put the sum in Gaussian elimination method. Do you identify Gaussian elimination method? Do you remember? Next, to convert the echelon form of the matrix become the system of equations. So we concluded it is in the system of equations. So we write the first one. You see the first row. It is a coefficient of x1 column, x2 column, x3 column, x4 column, and it is the RHS. So 2 into x1, so 2x1. This one is 0. Actually 0 into x2 is 0. Plus 0 into x3 is 0. Minus 1 into x4 is minus x4. Minus x4 is equal to 0. We already put in the starting equation 1, so I put it as equation 2. So the first row become one equation. Now we move in the second row. 0 into x1 is 0. Minus 2 into x2 is minus 2x2. Plus 1 into x3 is x3. Plus 2 into x4 is 2x4. Is equal to 0. Third equation. Next, the third row. 0 into x1 is 0. Plus 0 into x2 is 0. Minus 2 into x3 is minus 2x3. Plus 3 into x4 is 3x4. Is equal to 0. Now I put it as fourth equations. Now you see how many equations are there. How many equations? 1, 2, 3. And how many unknowns? x1, x2, x3, x4. x1, x2, x3, x4. 3 equations and 4 unknowns. Here before we see 3 equations and 2 unknowns, we can't solve. So we assign one variable as a constant. Here also we do the same process. There will be 3 equations and 4 unknowns. We can solve the equations directly. So we must assign any one of the variable is a constant. Generally we take the last variable treated as a constant. Here the last variable is x4. So put x4 is equal to t. Generally we take it as a t. But t is a real number. We need the value of x1, x2, x3, x4 all are a positive number. First of all, we will take it as a real number, then we filter all are positive numbers. So x4 is equal to t. So now I use the value of x4 in 2, 3 and 4. First I use the value of x4 in the second equation. Because there will be only 2 variables, x1 and x4. So 2x1 minus x4, we will take the value of x4 as t is equal to 0. We need the value of x1 only. So minus t becomes that side plus t. What about x1? The value of x1 is a t. Multiplication to become that side division. So the value of x1 is t by 2. Next, in the third equation, x2, x3, x4, 3 values are there. We have only the value of x1, but x1 is not there. Next, I see the fourth equation when x4 is there. Using the value of x4, I find the value of x3 also. So the next step, I use the value of x4 in 4. So fourth equation. 4 gives minus 2x3 plus, minus 2x3 plus 3 x4. We will take the value of x4 as t is equal to 0. We need the value of x3. Minus 2x3 is equal to minus 3t. Plus 3t becomes that side minus 3t. So x3 value is minus 3t divided by minus 2. The multiplication minus 2 becomes that side division. Minus by minus is always plus, you know very well. So the value of x3 is minus by minus is plus 3t by 2. So now we have the 3 values. There will be x4, x1, x3. Now using these three values to find the unknown, another one. What is another one? x2. So x4 over x1, x3. Next we using these values to find the value of x2 also. The next step is to find the value of this x2. So I again write the equation 3. Minus 2x2 plus x3 plus 2x4. So we don't have the value of x2. So minus 2x2 plus x3. The value of x3, you see, the value of x3 is 3t by 2. And the value of x4 is t. So using these two values, so the value of x3 is 3t by 2. So we use here 3t by 2 plus 2 times of x4 values. We already take it is t is equal to 0. So minus 2x2 plus 3t by 2 plus 2t is equal to 0. We need the value of x2 only. So I keep 3t by 2 plus 2t and minus 2x2 becomes that side plus 2x2. One fraction on whole number is there. So we cross multiply, we get 3t plus 2 to 4. 4t by 2 is equal to 2x2. 3t plus 40 is 70 by 2 is equal to 2x2. We need the value of x2. So multiplication 2 becomes that side, division 70 by 2 to 4 is equal to x2. So it is a value of x2. For our easy convenience, I write in order. Therefore, the value of x1. We already find the value of x1 is, you see, the value of x1 is t by 2. So the value of x1 is t by 2. And the value of x2, you see, the value of x2, 70 by 4. Comma. The value of x3, again we see, the value of x3 is 3t by 2. And x4 is just t. We already take the value of x4 is t. But this x1, x2, x3, x4 all are positive integers. But we take in before, but t is a real number. Okay, we put any real number, but this equation is satisfied. Now we substitute these values of x1, x2, x3, x4. So we need x1, x2, x3, x4 all are positive integer. So we will be taking the suitable values of t. It's very important. We will be taking the suitable values of t. The next line, but x1, x2, x3, x4 are a positive integer. Along positive integer. So it will be taking any values of t, but all values are from x1, x2, x3, x4 all are positive value. Suppose I will take the value t is 1, sir. 1 by 2 is not a positive integer. Okay, it's a fraction. So t value 1 is impossible. Suppose sir, I will take the value t is 2. Okay, 2 by 2, 1. Okay, x1 is a positive. But you see here 7, 2 by 4. We cancel, we get 7 by 2. 7 by 2 is not an integer. It is an integer. 2 cancel is also an integer, but x2 is not an integer. Now you identify, you put in which value of t? Is a multiple of 4, is better to write the least value. Suppose we will be taking the value of t is 4. 4 by 2, positive integer. 7 of 4 by 4, cancel, 7, positive integer. 4, second table possible, 4. So we will be taking only the positive values of x1, x2, x3, x4. So we put the value of a t is 4. Not only 4, it will take the multiple of 4. It will take 8, 12, 16, all values is possible, but it will take the least value. So using this value in x1, x2, x3, x4. Now x1, t by 2. The value of t is 4. 4 by 2, I cancel. The value of x1 is 2. Next, x2. The value of x2 is 7 or 4 by 4. We will be taking the value of t is 4. Cancel. The value of x2 is 7. x3. The value of x3 is 3t by 2. 3 of 4 by 2. In second table it is possible twice. So x3 is 3 to 7, 6. Last, x4. x4 if we take it is t, the value of t is 4. Now we put the value of t is 4, or we put 8, 12, 16 like this. But our final aim is all the values from x1, x2, x3, x4 are positive integers. Now you see all values are positive integers from x1, x2, x3 and x4. Now use this value in the first equation. I will take the first equation, it is the first equation. Now we use the value x1, the value of x1 is 2, x2 x6 plus x2, the value of x2 is 7. So 7 O2 gives x3 h2O, x3 6, h2O plus x4, the value of x4 is 4, 4 CO2. So which is the required chemical balance equation. You see in a chemistry we directly balanced, but we do the sum by using Gaussian elimination method. So it is a working rule to find the chemical equation of using Gaussian elimination method. What is the first step? Using the chemical balance equation, we find the unknown numbers 1, 2, 3, 4. So we will take the unknown numbers as from x1 to x4. The next step, we equating the compounds, that is the carbon, hydrogen and oxygens. We equating some equations is given, that is to form the system of equation. Using the system of equations, the next step is the matrix form, and then the augmented matrix, then to convert in echelon form. Again the matrix form is converted in the system of equations. Using these equations to solve, to find the values of from x1, x2, x3, x4. Values are there, but important, it has infinitely many solutions, but we need only positive integer solution. So all are positive integer, we will be taking the suitable values of t. Using the values of x1, x2, x3, x4, we will be taking the suitable values of 4. Suppose the sum occur except 4, 8 is there. So we will be taking the value of t is 8. Suppose 12 is there, we will be taking the value of t is 12. So using these values of x1, x2, x3, x4, we will be taking the suitable value of t. Suppose we will be taking the value of t, all are positive integers. Then we substitute the values x1, x2, x3, x4 in the given equations. So it is the required chemical balance equation. The same model questions and the related problem lies in examples. We must try. It is our same working rule to find any chemical balance equations.